write a program to swap two numbers. This can be implemented with different methods. So let's start with the easiest one. Let's say we have two variables a and b. Let's take one more temporary variable temp. The logic is very simple. What we're going to do is in the temp we're going to store the a, then in a we're going to store b, then in b we're going to send back the temp variable. Let me show this with an example. Let's say we have a as 5 and b is 4. In step 1 what we are doing is temp we are storing the value of a. So temp will hold 5. Then what we are doing, b we are putting into a. So a has to be turned to b, that is 4. Then temp is put into the b. So in b we are putting 5. I hope this is very clear. 5, 4 has turned to 4 and 5. This is approach 1. Let's quickly implement it on the machine. Now let's write a program to swap the numbers. So here let me take two variables a, b. Let me also take the temp variable, and the first integer will store it as a, then enter the second integer, let's store it as b. Now the first method, logic with three variables. So in temp we're going to store a, then in a we're going to store b, then in b we're going to store temp. That's it. I think this should work. Let's print the numbers. The numbers after the swap are so and so. Alright, let's execute this. First let me compile it. Okay, it's compiled, no errors. Okay, 9 is available. Okay, enter the first digit 5, 6. The numbers after swap is 6 and 5. Absolutely working. So we have learned the implementation using method 1, that is using a temporary variable. Secondly, using a swap function. Now we can also do this with a function. So let me take a function void swap. Here what we're going to do is we'll send these variables a and b with address. So here we're going to take the pointers. So int, we are sending these two addresses, so we are taking as pointers. For timing, let me comment this. Okay, now let's write the function void swap int star a and int star b. So basically this star says that whatever the values you're sending with the address. So any change will be permanent, so that will be reflecting over here. If you do not put this star, what happens is a copy of these values will be sent. Any changes will not reflect back. So in order to have the changes, we need to have the pointers. So this is called by reference. So here let me take the temp value, then temp equals a, then a is b, we're swapping the address, then b equals temp. Alright, and here we're gonna use the swap function. Swap, we're gonna send the address of a, address of b. Alright, this is the second one, second logic using swap function. Okay, let's try. Okay, no errors. 5, 6, 6, 5, absolutely working. Sometimes in some interviews they will say that we should not use a third variable. So let's go with the third method, that is implementation with only two variables. Here the logic will be, first what we'll do is we'll add both a and b and we'll store it into a, then b is a minus b, then again a will be a minus b. When we do this iteration, numbers will be automatically swapped. Let me show this with an example. Let's use the same values a and b as 5 and 4. Let me draw some lines for reference. Okay, after the first iteration, what we are doing is we are adding a and b and we are storing it in a. So when we add 5 and 4, it is 9. 9 we are going to store in a. B is as it is, that is 4. The second iteration, what happens? From a we are subtracting b. So from 9, if you subtract 4, it is 5. 5 is stored in b. So 5 will be over here. A is as it is, so it will be 9. After that, then from a we are subtracting b. So from 9, if you subtract 5, it is 4. 4 we are storing in a, and b is as it is. Now check these two. Initially it was 5, 4. Now end of this iteration we have 4 and 5. That's a swap. Now let's code this on the machine and let's compile and see if it works or not. Okay, now let's go with the third technique. Let me comment this with two variables only. So as we have discussed, it will be a equals a plus b, then b equals a minus b, and again a equals a minus b. Let's compare and see if this works. Okay, 5 6 6 5, absolutely working. Now let's get into the fourth method of swapping numbers. Here we're going to use bitwise operator XOR. Now for convenience, let me write its truth table. Let's say we have a, b, and a XOR b. So 1 1 1 0 0 1 0 0. These are the possible values for a and b. Just keep in mind, XOR is basically whenever there is no change, that is in both it is 1 1, or if both it is 0 0, we're going to take XOR as 0. If there is a change 1 0 or 0 1, it will be 1. Alright. Now for convenience, let me take some example values for a and b. A, let me take it as 5 and B as 4. Because we are dealing with the bitwise operator, let me convert these numbers to binary. 5 is 101 and 4 is 100. And the implementation logic is A equals A XOR B, then B is A XOR B, then again A is A XOR B. This is the logic for this particular program. So let me show this with an example. A we are taking as 5, so 101. B we are taking as 4, that is 100. The first step is A XOR B. So A is 101, B is 100. Now what we are doing is A XOR B. So we're gonna do bit by bit. So look at the first two bits, 1 0. So 1 0 it is 1, 0 0, 0 0 is 0, 1 1 is 0. Alright, so we got this. Now this we are storing it in A. That is the first iteration. So let me write the values. So A will be changed to 0 0 1. B remains same, so 100. Now going to the second iteration, basically we are doing XOR with A and B again. So this is the new value of A. B is 100. Now again let's do it bit by bit. Here it will be 1. This is 0 and this is 1. This is the new A XOR B. This we are storing it in B. So 1 0 1. A remains same, 0 0 1. After this we are going to the third one. So this is the new value of B. A is 0 0 1. Let's do again XOR. A XOR B will be 1 0 0. This we are storing in A. 1 0 0. B remains same, 1 0 1. Now look at the initial value and the final values. You can clearly see the numbers got swapped. Alright, let's implement this on the machine. Okay, now let's go with the fourth method with bitwise operator XOR. So here the logic is A equals A XOR B, then B equals A XOR B, again A equals A XOR B. Now let's check with this. 5 6, absolutely working. So you can use any of the four techniques. Now sometimes the interviewers are very specific, they don't want this very simple logic. They may ask you question based on the call by reference, or they may say just go with the bitwise operators and do it. So then you can go with this logic. I hope you're clear with this.